Hey, how you guys doing? So I'm here to talk to you guys today about equivalent ratios. I don't necessarily have a hack for you, but I do just want to go through the ways that I would solve equivalent ratios, not using a ratio table. There will be another video that I'm going to make about equivalent ratios, specifically whenever you're given a ratio table and you have to find missing pieces. You have to complete the table. So number one, when you're given equivalent ratios, or when you're given two ratios and they're like, are they equivalent or not? This is what you want to do. Number one, this is what I do. I like to set, I'll be right back. Okay, so if you want to go ahead and pause your screen and write these things down, I'm going to go ahead and walk through them and explain them to you. So when I'm given these equivalent, or not equivalent, I'm sorry. When I'm given two ratios or rates, whatever it may be, what I do is I go ahead and I set up the rates or ratios as a fraction. So for example, I would take this is a rate in this case because it's comparing money and feet. One measures money, one measures distance. So they're two different measurements. I'm just teaching that at the time, so I like to label them as well to make sure I don't put them in the wrong spot. And then I set up the other one. Okay, and so what I do before I go to step two, because sometimes you don't have to cross multiply. Sometimes you could just solve the problem much easier. So you want to check for a relationship. So what I mean by that, there could be a relationship left to right, and there could be a relationship up and down. So what I mean by that is this. Can I go from 9 to 12 by multiplying or dividing? No, I cannot. Okay, can I go from 12 to 16 by multiplying or dividing? No, I cannot. And then I look up and down. Can I go from 9 to 12? No. Can I go from 12 to 16? No. So in this case, since I cannot find a relationship, and this would be like, if this was 2 and this was 16, 2 times 8 would be 16, which you do the top, you do the bottom. But that's not the case here. So what I would do at this point is I was cross multiply. So 12 times 12 is 144. Okay? And then 9 times 16 is actually also 144. So these numbers are the same. So that means these are equal. Yes, these are equivalent ratios or rates. All right, example number 2. I have 4 tons every 10 years and 2 tons every 5 years. Once again, this is a rate, but once I said, I definitely have been teaching rates, so I'm stuck in the rate frame. So here we go. I would, number 1, set them up as ratios. So I would put 4t for tons over 10 y for years. And then I would have 2t for tons over 5 y for years. You could not put the 5 up here because then it would be 4t is next to 5y. So that represents years. This is tons. So if the tons is on top, the tons is on top over here. You feel me? Cool. All right, so now let's look for a relationship. I already see many relationships right here. So I can go from 5 to 10, right? Times what? How do I get from 5 to 10 by multiplying? Because I'm going up, which means I have to multiply. I multiply by 2. So what I do to the bottom, I do to the top. And 2 times 2 is 4. So yes, they are equivalent. All right, example number 3. I'm given my ratios like this, 2 to 4 and 1 to 3. So I'm gonna still, number 1, set them up as fractions. And this is not like the only way that you can solve equivalent ratios. It's just something that is helpful for me. It's just how I do it. I feel like it's quicker. I prefer to multiply than divide. So that's what it is for me. You could also like throw them in a T-chart and see if they all reduce down to the same thing. You could just find the unit rate or unit ratio or whatever it may be. But sometimes you can't always turn it into one. But if they reduce to the same number, they would be equivalent as well. So for example, I'll do the T-chart as well. So I'm gonna look for a relationship. For example, can I go from 3 to 4? No. Can I go from 4 to 3? No. Can I go from 1 to 2? Yes. And I would do that times 2. What I do to the top, I do to the bottom. Is 3 times 2 4? No. It's 6. So then no, these would not be equivalent ratios. I do want to point this out. If you look right here, I also have a relationship between my top and my bottom. Look, I can get from 2 to 4 and I can go from 1 to 3. So in that case, can I go from 1 to 3? Yes. Times 3. 2 times 3 is 6, not 4. So once again, these would not be equivalent. All right, last one. So I am going to show you using the T-chart on this one. So pretty much if they just reduce down to the same number, they'll be good. So I'm going to start with 18 to 12, mostly because 3 and 2, you can't reduce them. So here we go. I would take out a 2 and I would be left with 9 and 6. And looking at 9 and 6, there is a number that equals that. Both of those numbers, and it is 3. 3 times 3 is 9, and 3 times 2 is 6. Ah, look. 3 to 2, 3 to 2. So yes, they would be equivalent. And if you wanted to see it as the situation I told you already, I can go from 2 to 12 by multiplying by 6. So what I do to the bottom, I do to the top. Does 3 equal 6? Yes, they are equivalent. Bye. Oh, let me move out of the way for a second. Did you see it? You see it? You got it? Great. Bye.